Okay, onward and upward to a new chapter in Algebra 2. This is going to be all about rational expressions, but there's also roots and radicals at the end. Rational expressions are polynomials, a version of fractions. So yeah, this is a bit of a challenging chapter, at least in Math 110 it is, in beginning algebras. But here we go. Let's do our best on this. It says we're going to take it to a whole nother level in terms, and what I mean by that jokingly is that there's going to be a numerator, there's going to be a denominator, we got to worry about all the arithmetic of fractions. But we make it systematic, we do it, and we do it, and we get the moves down, and actually this becomes it's a little more work with factoring, but we open up new doors. It's a good section on, it's indispensable. We have to be able to do this. So stop talking and do it, Weber. Okay, so the topics are, hey, when I write a rational expression, and by the way, I'll circle one right now down here. That's what we mean by a rational expression. What it is it's a polynomial divided by another polynomial. And when is it undefined? What x values are not in the domain? That's what we're going to talk about on the first video of this section, and also how to simplify using FCR, so to speak. I made that one up. Anyway, that's what we're going to talk about in the first one. The second video is going to deal with how to multiply and divide, but we got to get this one done first. So here we are. When a rational expression is undefined, it means you're dividing by 0 typically is a problem, okay? So whenever the denominator is equal to 0, the expression is undefined, okay? Whenever the denominator is 0, the expression is undefined. Okay, so there's some notes here, but what I mean is, let's goof around with this guy. Let's say we have a function let's say we have 3x minus 1 all over 2x squared plus 3x. Okay, we can plug in, let's say that's y. We can find a whole bunch of ordered pairs as much as we wanted to. We could just keep on plugging numbers in, like 3, for instance, would give us 3 times 3 is 9 minus 1 all over 2 times 9 plus 9, whatever. But there are numbers that when you plug them in, it causes divide by 0. And that means that where is it undefined? Let's find out. So what we do is we take this guy and we realize a number, if you divide by 0, you're causing this expression to be 0. So really, what x values cause the denominator, which is 2x squared plus 3x equal to 0? Because if it is, it causes divide by 0. Okay, so that's the logic. The logic is, hey, I'm going to look at that denominator, which is 2x squared plus 3x. You know what I'm going to do? I'm going to set it equal to 0, and I'm going to find the x that makes it 0 by solving. So really, set denom equal to 0 and solve for x. Look at this equation. It's got a GCF. Did you know that? 2x plus 3 is left behind. We've done this. Last chapter, we were doing this kind of stuff. So the two answers are, what I see, this guy gives us x is 0. This one gives us 2x plus 3 is 0, or 2x is negative 3, or x is negative 3 over 2. And you've done it. The answer is it's undefined when x is equal to 0 or negative 3 over 2. So a question in my math lab would say, hey, where's this undefined? That's how you do it. Another question in my math lab is, hey, what's the domain of this function? I see a typo up there. So up here, this is a quick answer if we've done the work already. So find the domain of f of x is equal to this thing, which is, what did I say it was? The top is 3x minus 1 all over 2x squared plus 3x. So I'm just writing it there for reference because we already know, hey, basically it's defined everywhere except when, say, let's see, x is equal to 0 or negative 3 over 2. Okay, I think I was wanting me to do examples right here in this space, so I might have to scroll down and do another one, maybe pick one from the book or whatever, or have you do one. So but here's how you answer a domain question. So the domain is this. You better not be negative 3 over 2. You better not be 0. Otherwise, you're good. You're golden. So what I'm scribbling in is, that's actually the domain. So you could say the domain is from minus infinity, I'll do this guy right here I'm coloring in more, to minus 3 over 2, and then union minus 3 over 2 to 0, and then union one more, 0 to infinity. It's kind of fancy, but that's what they want you to be able to also do. Hey, I can state where it's undefined, but I can also do the flip of that and say, here's where it is defined. That is the domain of the function. So that's how you find, in fact, I think I'll stick with just one of those. You can do as many as you want. The next thing would be to simplify. If I wanted to do another one, maybe I'll scroll way down here past all these notes and pick out another one. I'll do it maybe here. Domain of maybe g of x is equal to 2x plus 5 divided by x squared minus 2x minus 3. If I'm in a hurry, I do the following work. I just simply go, okay, for the domain, I'm going to find where g of x is undefined first. And that's where the denom, which is x squared minus 2x minus 3, is 0. And I solve for x. So I'm going to factor that thing, x minus 3, x plus 1. I'm going to solve it. X is negative 1 or 3, and that's where it's undefined. But someone said, what's the domain? Well, the domain is everything else. So mark off minus 1, no good. Mark off 3, no good. But that's good. That's good. That's good. So the domain is equal to the following intervals. It's going to be minus infinity to minus 1. That's this one. Union minus 1 to 3. Union 3 to infinity. So we get all those intervals, and there's another example. Okay? Pause, but I'm going to scroll. Okay, so I have the next section here, and the next piece of this tape is the following. We're going to simplify rational expressions. This might take a little bit of time, thinking about making it a new video, and maybe I will. So I'm going to pause it.